Hello and welcome to this JavaScript Promises tutorial. My name is Maximiliano Firtman. I'm a mobile web developer. You can find me on different social networks with @Firt or Firt.dev. And today, I promise you that you will learn about JavaScript promises in just a few minutes. So let's start. Let's start with the first question. What's a promise? So let's pretend that we're going to a Starbucks, to a coffee shop because we want a coffee. And there are two ways these days that you can go and order for coffee. You can go to the shop, to the physical shop, or you can use the app. And in both situations, you make an order. So in this case, we are calling an order function, passing, for example, the items that you want, such as I want a latte and a pound cake, and then the credit card or the cash, so a payment method. And the function will do something. If you think about that, what is this function returning? So what about the type? Are we returning like an array of products or item? Something like this? Think about this for a second. On the app, or when you go to the physical store, what happens when you make an order? What do you receive in return immediately? You don't get the coffee or the cake. You actually get something like this, a receipt. It can be a physical receipt or a digital one on the app, but you don't get the coffee yet. So, and that's a promise. So actually this piece of paper is a promise of a coffee and a cake that hopefully will arrive later. Why am I saying hopefully? Because most of the time you will get the coffee and the pound cake. But sometimes there are problems. I don't know, they don't have more stock for the pound cake, or there was a problem with the coffee machine, and then you won't get your coffee. So a promise can be fulfilled or it can be rejected. And if you understand that, then you are currently understanding promises in JavaScript, because that's a promise. A promise is just a design pattern that is currently available on many languages, including JavaScript. So in JavaScript, it was included in ECMAScript 6, and also a couple of additions have appeared in ES 2017, ES 2024, and so on. And from a JavaScript point of view, then, we are not returning the items, we are returning a promise of items. And that's how we set this in data type annotation in JavaScript or even in TypeScript. It's promise with capital P, that's actually the JavaScript constructor, and then angle brackets and the thing that you will return later. In most languages, when you are returning or you have a promise, you don't have the thing. You are not returning the thing, but a promise of that thing for later. Here at NDN Web Docs, you can see the promise object and actually browse through all the constructors, static methods, instant methods, and some code samples as the ones that we will see in the rest of the video. When you use promises, you're also creating vocabulary that is common among other developers when you are designing your API. So when you have an API and you see that the API is promise-based, you know exactly how it works. You know how to consume that API. Before promises with callbacks and other async mechanisms, we didn't have like an option to know beforehand how the API will look like. We had to go to the documentation and understand how that API works. When it's a promise, we have a common vocabulary among all the developers. A promise can actually be in one of three possible states. Pending is the initial default state when you create the promise, and we will see how in a second. That promise is pending. So I have the receipt and I'm waiting for the result of that operation, of my order. The promise can also be fulfilled, meaning that the operation was completed successfully and the data that you were waiting for is actually ready for you, and rejected, which means the operation failed for whatever reason. Have in mind, and this is important, If, for example, you are making a search operation, like searching in a database and you're returning a promise, if the user is searching for something and the search operation returns no results, that's not a rejection. Those are actually values that can be possible in that operation. You reject the operation when you couldn't make the action, such as the database is offline, so I cannot even go and search for what you're looking for. A promise can actually be pending forever. It depends on something known as the executor. The executor of a promise is a function that will actually make the job and will make a decision in the future, synchronously or asynchronously, if that promise will be fulfilled or rejected. But if you have an empty executor, or the executor never makes a decision, that promise will be pending forever. Finally, it's important to understand that we use promises only in one particular situation, when that event will happen once and only once. So for example, if you're making an HTTP request, you can get the response, and that's all. You are not going to get more than one response. You cannot use the promise design pattern for operations where you are receiving multiple events, multiple hits. So for example, if you're using WebSockets, you shouldn't be using promises, because on WebSocket you can receive multiple messages from the server. Promises will not be useful for events that will happen or will be fired more than once. One way to create a promise is to use the new promise constructor. The promise constructor receives the executor as the first argument. What's the executor? Another function. So it's another function. We can use the function keyword or an arrow function. And that executor actually will have the signature with two arguments. We have resolve and reject. What's the idea? Within that function, so within the executor, this is the executor, within the executor, we are going to call resolve or reject based on the actions. So for example, I can actually check if math.random is greater than 0.5. Math.random will give us a number between 0 and 1. So we can say that if it's greater than 50%, we will resolve the promise with a message like done. In this case, the promise is returning a string. So it's promising a string. And then if not, we can reject the promise. When we reject the promise, we are not forced to reject with the same type as we are resolving. In fact, the common design pattern is to reject with an error. That is actually the constructor in JavaScript that we use for exceptions. So typically, we always reject with an error. In this case, it can be, it didn't work. Of course, this is just a demo. We create the promise has one argument, that's a function, and that function within the code block will make some sync operation or async operation, such as going to the network, wait for the browser to do something, whatever. And at some point, it will resolve the promise saying, hey, here you have your coffee, or it will reject the promise saying, I'm sorry, we couldn't make that operation. This is a promise, so we can actually save this into a variable if we want, or we can return a promise when we are in a function. So when you have a function that returns a promise that will, for example, promise for a coffee, will actually return a new promise with something like that. So that's the classic way to create a promise. We can use some shortcuts, some factory methods that will create promises that will be automatically resolved or automatically rejected. So for example, promise.resolve will resolve the promise with some data. Any value, any JavaScript value can be used as the value that you're promising. So in this case, I can resolve with a Boolean, for example. So then this promise is automatically resolved. And also we can reject promises using promise reject. And then the reason is the same as we were doing here. So actually it should be based on the design pattern, a new error, explaining what happened when you want to automatically create a promise that is rejected. These are the two classic ways to create promises based on the standard created in 2015 on ECMAScript 6. But 2 years later, on ES 2017, another way to create promises that is pretty cool. Actually, it's not to create promises, but to create functions that returns promises automatically. And that's the async function. When we return a value, for example, hello, when we think about the data type that this function is returning, when you look at it initially, you may think, oh, that's a string, right? So it's returning a string. But no, because it's an async function, the async function always returns an implicit promise. So actually, this is going to be a promise of a string. Have that in mind. So every time you have async, whatever you're returning is not really the return type or the type that is going to be used based on that value. It's going to be a promise. Okay, have that in mind. So for example, we can convert promise coffee here with another version. I don't need to explicitly create a new promise because async will do that for me. So in that case, I will just copy this, paste this here, and I will say, well, based on that random number, instead of resolving, I will just say return. Because if it's an async function, when you return, you are returning a promise. And what about rejection? So, because if I return, it's actually going to resolve the promise. So in this case, the async function becomes the executor that creates a promise on the fly for me. So instead of rejecting, I will throw the error. Just by throwing an exception or an error in JavaScript within an async function, that will reject the promise that we are returning. So here you have all the options that we have available to create a new promise, to promise something to someone else. Something to have in mind is that when we create a promise, for example, when we are returning a new promise, so we create the promise, or when we have an async function and we execute the function, the executor executes immediately. So that means it's not waiting for someone to be expecting the response, the result for this promise operation. It immediately executes the executor, even if no one is waiting for that coffee. And the same happens in the real Starbucks. I mean, if you order something from your phone or from in the real world, and then you go out and you never go and pick up your coffee, the executor, so the barista, will make your coffee anyway. It's not waiting to see if you're there waiting for the coffee. Okay, does it make sense? So the same happens here. So as soon as you create the promise, so for example, you call new promise, the executor, so the code that we have inside, will be executed immediately. Here I have a getRate function that is async, which means it's returning a promise that will convert from US dollars to euros. So it's giving me the conversion rate, the currency conversion rate. And remember, in this case, it's returning a promise of a number. That's the current type. So if I want to execute this, so let's say we create a rate property and we call getRate. Initially, when you look at that code, you say, yeah, it's fine, right? So getRate, it's giving me the rate, so I'm saving it into a variable. But actually, because it's returning a promise, rate, it's now a promise, not the number. So rate, it's the receipt. So it's not really the number. So maybe you're thinking, oh, but can I get the dot value or something like that? No, not really. We have to wait for it. So then that means that you don't consume promises in this way. So you need to take that promise, that rate promise, and so let's change the name first. So it's not the rate, it's the promise of a rate. So let's say promise rate. And then we need to wait and listen for that promise to be fulfilled. And for that, we use the then function that receives another function as an argument that will act as a callback. So it can be a function that you define somewhere else, or it can be typically you use a literal anonymous function, an arrow function or normal function. So you can say something like this, or you can use arrow functions that looks like this. And we're going to get the rate as the argument. That's the idea. So now that 0.90 will go to the rate here. So now we can console log this and say the rate is with the rate, but not before. So we have to wait with .then. This is the classic way to consume promises. The other way is to use the pair of the async attribute that is known as await. Await works in this way. So in this case, we are going to receive the rate, not the promise. When we call getRate, we are going to await for that promise to be fulfilled. Okay, so that's how it works. And there are a couple of situations that we need to understand. To use await, we have some requirements. In standard normal JavaScript, the await must be in a function call. So I need to put this in a function. It doesn't need to be in the top level of my JS file. So I need to create a function, start, then execute this, and finally, of course, execute the start function to actually make that work. And now we see we have an error here. And when we look at the error, it would say that await expressions are only allowed within async function, which means this start function must be an async function. Okay, so that's mandatory. So now it's exactly the same. So now that I do have the rate, I can do the same console log that I have here. So I can just put this here. And actually, these two versions are doing exactly the same. So await, it's syntax sugar for using the then way to consume promises. So you pick the one you prefer. So in the same code, sometimes you can use await and sometimes you can use then. Await can also be used outside of an async function only in two situations. On ES modules, so when you have an ECMAScript module, a separate JS file within an ES module, you can use top-level await, that's the name, and also you can use top-level await without a function, and also you can use top-level await, so without an async function, within console debuggers in the browsers. So for example, now in the console within DevTools in Chrome, we can make a fetch to an API. Fetch returns a promise. So if I hit here, you can see that initially the promise is pending, so I'm getting a promise. And if I open this after a few seconds, this promise was fulfilled. But I'm getting the promise. So I can actually say I want to await for that promise to finish. And now I'm getting a response, a different type of object. Instead of a promise, I'm getting a response. And now, for example, I can just take that await and execute a JSON function that returns another promise. So I can also await for the other promise. And finally, I'm getting the result of this call, the data. But you can only use await without an async function within the console in DevTools, in Firefox, in Chromium-based browsers, Chrome and Edge, and also in the Web Inspector in Safari, or within your code, Node.js or browser-based, it must be in an AS module. If it's not in an AS module, you need actually a function wrapper, and that function needs to be async. So now we have two ways to consume a promise. We can wait for it using then, or we can wait for it using await within an async function most of the time. But in this case, it's a promise that is always resolving with a number. There is no rejection here. This is the executor of the promise, and it's always returning a real number. But what happens if we go and get the rate from a real API? So, for example, we had that URL that we used before to get a JSON from the network. It's an API, it's actually working. So I want to do a fetch, so I will first try to get the response from awaiting for a fetch API on that URL. Remember, fetch returns a promise of a response. So I'm awaiting for it, so now response is not a promise because I awaited for it, so it's actually the response. And then I need to get the data, awaiting for that response for the JSON parsing to finish. And JSON is another function that you can actually check in the fetch API documentation that returns a promise. So actually now I have the data, so instead of returning 090, I can return data.rates.ur. That's actually the schema for that JSON. So what if there is an error within the fetch operation, such as the API is offline or we don't have connection? So anything can happen. In this case, I need to understand how to work with errors. We have three ways to listen for errors when working with promises. The first one is to use the then design pattern. There is a second argument to then. This is the callback for succeed, so when the promise was resolved, and we can have a second one that will be executed when that promise was actually cancelled or rejected. That's one way. The other way, that to be honest is probably the most common one, is to use another function over the promise. It's called catch. Catch will catch any errors over that promise, so then we can see it differently in a different function. It looks better. So I think it's recommended over the double callback on the then. But also, when we are using await, how can we listen for errors? Because await, it's always for the then, only for when the promise is actually happening without any errors. So when we are using async and await, we can use try catch. The try catch is typically for synchronous code, but when we are in an async function, it also works with async code, and in that case it will trap your exceptions that also happens within a promise. So I will try to get the rate, and I can catch the error in a catch and do something different, such as console log, we couldn't get the rate. And by the way, we can also do this here as well, so we have the same code twice. So now we have the way to capture when the promise is resolved through then and through await, and when the promise is rejected through catch, a second argument on then, or try catch when we are using async. To finish this idea of consuming a promise, we also have finally. Finally will be executed no matter how the promise finish execution. It can be resolved or rejected, and finally will execute some code at the end. So for example, we can do console log end. And when we're using an async function, the finally works with the try block, and we can do the same thing. Now that you know this, maybe when you look at this code, it doesn't look so nice, and probably you have seen the code differently. And yeah, that's true. So let me try to make this code, I'm talking about the code that is not the async await code, to make it clearer. Because I didn't mention that the then, the catch, and the finally functions are returning promises as well. Which means, if I'm returning a promise, I can chain them. So, most of the time, we are not creating a constant or a variable for the promise. It's not common. I mean, you can, this code is perfectly valid, but it's not really the common use case. Typically, we call getRate without saving the promise, and then we chain the then directly over the execution return. And then we can continue the chain. So we remove the semicolon here, and we chain the catch. And we do the same with the finally, like so. So now it's only one line of execution. It goes over then, it returns a promise that goes over the catch, it returns a promise that goes over finally. So we have only one semicolon at the end. It's just one expression. And we can make this even better. Most of the time, we go to a new line here. Most of the time, we cut the line here at that moment, like so. And then we indent this in this way, like that, that, and that. So, okay, it's becoming nicer. Okay, it's becoming nicer. And because we're using arrow functions here, when you have arrow functions, you have some abilities. For example, on those abilities, if it's only one line of code, you can get rid of the code blocks. So I can get rid of the code block here, like so, that. And the same happens here because I only have one call, like so, and then the finally. So it's just the same code. I'm just refactoring the same code, but now it looks better. Remember, only one semicolon at the end. If you add semicolons here, it's not going to work. Okay, so because it's just one execution at once. So when you are not using async await, this is the other way that you have to consume promises and make the code clear. Something to have in mind though, when you're using await and you are in an async function, is that start, it's actually returning a promise. So maybe when we don't have a return, there is an implicit return at the end, always in JavaScript. So the thing is that even if you are returning nothing, that means that the start promise, in case someone wants to listen for that promise, because it's a promise, because it's an async function, will actually be fulfilled. But if it's an error, if there is an error, we may have a problem because there is an implicit return on that situation. So start will actually be resolved even if we had an error in getRate. So instead of doing that, don't return on the catch. Throw the error. So if the error that you receive as an argument. So if you throw the error, then this async will be rejected as well. So the promise of a start won't be fulfilled. The promise will actually be rejected. Now let's make this code a little bit more complicated. So what if we also have a function, an async function, so it will be a promise, that we get the price of a coffee. And let's say that in the future, so we can add a to-do comment here, we need to go to a real database. But now we can just say, you know what, we receive an ID, let's say from a product, and we're going to return math.random let's say, multiply by 400 plus 100. That will give us a number between 100 and 499. So that's a random price, okay? And remember, because it's async, we are returning a promise. Even, this is important, even if right now we are not doing anything asynchronously, so getting random is a sync operation, it's a good idea to create a lot of functions as async functions or as promises. Why? Even if it's a tax, I don't know, you create a constant and you say, okay, the tax is 10%, right? Well, the tax rate might change in the future, or maybe in the future you will go to a database or to an API. So future thinking, it might be a good idea to say, you know what, I will say that this is a promise that right now we resolve to 10, but maybe in the future we change the implementation. But thinking about promises beforehand then makes all your consumers thinking that your data is promise-based, everything that you are offering is promise-based, so then you can change implementation in the future without needing to change the consumer. That's kind of a tip. Anyway, let's go back to the price idea. So now, after we get the rate, then we can go, we have the rate, and let's say we have the price in USD and US dollars. So we need to convert this into euros. That's our goal. So then when we have the rate, instead of doing console log, maybe what I want is to get the price for an ID, let's say ID 45. Get price returns a promise. So I can do another then. So then I can go back here and say, well, then, and then I get the price. And we can adjust this like this. Okay, so we get the price and we get the then. We also have its own catch because another promise. So then I can now say the price in euros. So price in euros is, and we're going to take the price and we're going to multiply that by the rate. So we have the price for this promise and the rate for the other promise. It should work. But if you look at this code, it's okay, it's working. We can make it better. In this case, what we have is a sequence, or we are executing two promises in sequence. Later we will see if sequence is the best way, but it's a sequence. So first we get the rate, and when we have the rate, we get the price of the product. So when we have these situations where you want to execute a lot of promises in sequence and you're using the then design pattern, you can do this. Get price 45 is actually returning a promise. So something that we can do is we can return this directly to the then, and because we don't have a call block, so if we have a call block, it should be like this, okay? But because we don't have a call block in JavaScript, we have an implicit return, so we don't need the return. And we can close the parentheses of the then immediately. So then we don't need this one. And this then can be chained here. Let's try to understand it. And actually, I can get rid of the call block as well here. So when you have a sequence of different promises, you can change the then. If the first then is returning another promise, that other promise will go to another then. And if you want here, you can just share the same catch for both then. And you can add more. So instead of doing console log, maybe here you have a calculate final price where you pass the price and the rate, for example, like so. So then you will have another then that will get the final price. And you will do something with that final price, such as sending the final price to console log. So you can apply one then after the other, and it will just work. How to do the same, so sequence With async await, it's pretty simple. So you get the rate, and then you say, well, I have the rate, now let's get the price. So then we get the price for 45. So now we have the price. So the final price is price multiplied by rate. So, and get price returns a promise. So I need to await for it. So I can have more than one await in one async function. That's perfectly valid. And in this case, we have only one catch because we have only one try block. But if we want, we can just have a smaller context for try catch in case you want to catch specific different kind of errors. But if you think about this for a second, executing get rate and get price in both situations in sequence doesn't make too much sense in this particular example. I don't need to wait for the rate to actually get the price, because maybe the rate is coming from an API in one server and the price is coming from a database. I can do both in parallel instead of using sequence. So let's see how the Promise API let us work with promises in parallel. Let's modify a little bit our example, and now we have a get rate A from an A provider from our API and get rate B from Frankfurter. So in this case, both are giving me the USD to Euro rate, but different providers. Okay. Then we have get price, that is giving me the random price, and add tax, that receives a price and it will add a tax. And the tax is hard coded here, but as we mentioned before, you may want to change that later for the promise-based API. Why do we have two rates? Well, because maybe one is offline, so I have a backup. That's one idea. And the other one is that I can make some kind of a race between the two providers and see which one is faster. And even if one is failing, I can use the other one. And the Promise API will let us execute both in parallel and try to get one answer. So in the browser, I will paste these two functions. So now I can call them and I can wait for them if I want to. Get rate A. So it's giving me the number, and get rate V. It's giving me a similar number but different, two different providers. The data is coming from different sources. So let's try now different APIs that we have available to execute multiple promises in parallel. All these functions are static methods of the promise constructor. So let's start with promise all. Promise all will receive an array of promises. So I can just say get rate A, I'm executing it, and get rate B, I'm executing it, I'm closing the list. And it's a promise, so promise all returns another promise, which means I may want to await for that other promise. And actually, it's giving me an array of each result. So promise all will actually be resolved properly, successfully, if all the promises in the array ends properly. And if one, or at least one, is being rejected, it will reject the whole promise all. So all of them must be returned with the value, no errors. Instead of promise all, we can use all settle. That's a new one that has appeared recently. In this case, it's returning me with objects, explaining to me what happened. So in this case, it will always resolve. So it's a promise that is always resolved, and it will be resolved with an object saying the status of each individual promise and the final value. And then we also have promise race. Promise race will actually act as the fastest promise of the list. So if A is the fastest one, if A is actually returning properly the value, I will get the value. If A is the fastest one and it's rejecting, promise race will reject. So promise race is not guaranteeing a value, it's guaranteeing the first answer. Okay, so it's giving us the first answer. And promise any will try to get the fastest value. Okay, value. To be honest, any is one of the most useful ones, because in this case, it will give me the fastest provider, the data coming from the fastest provider. So coming back in our code, we have these three async functions, and we have one function that is not returning a promise. So it's not promise-based, but we can also make it promise-based. Even if you feel like it's just a normal function, we can make it an async function, so it returns a promise, and we can put this function also in the promise engine to execute promises in sequence or in parallel. I can create an async function that will make the final price calculation. Remember, we are trying to get the final price of a product in euros. So we can try to first get the price with tax. It's going to be get price, but get price is promise based, so I'm going to await for that price, and then we are going to add the tax to that price. And because this is also a promise, I need to await for it. And this is perfectly valid. Then I need to get the rate between US dollars and euros, because this price is in US dollars. So I will say, okay, we can talk to our promise any API. So we pass an array of get rate A, get rate B, an array of promises, and then rate will get the fastest one. Okay? The thing is that we are doing this in sequence. This is executing first, and this is executing after. But do we need to wait for the price and the tax to get the rate? Not really. So what if we change this and now we use promise all to execute two in parallel, two promises or more in parallel. So we pass an array, and the array will contain two promises. So one promise is add tax. I should get rid of the await, because I don't need to await for the promise. So I will take this as my first argument for add for promise all. And the second one is also this one with no await. Right? Does it make sense? So now I'm executing both in parallel because there are no dependencies between each other. Two completely separate things. So promise all returns a promise. So we can use then to listen for that promise values, or we can await for the values. So we receive values now in return. How many? Two, because there are two promises, the price and the rate. And instead of treating values as an array, I can just destructure this into price and rate, and then do a console log saying the final price in euros is price multiplied by rate. Pretty cool, right? So now we mixed a lot of stuff in promises at the same time. We are executing in sequence. Here we have get price first, then add tax, so that's a sequence. And then we are executing promises in parallel in different ways, with all in parallel, and we want to get both values, and with any, where we also execute in parallel, but we only want one value, the fastest one. So now I can go to the browser and execute await final price, and now we can see a final price in euros. And that's the magic of promise. So I hope that my promise is now fulfilled, and now you understand how to use promises in JavaScript. It's time for my real coffee.